Hi, boys and girls. Welcome back. I'm Mr. Peck. Now, we are in the fourth question in chapter 4, forces. Okay, let us read the question together. Figure above shows a crate A of mass 2 kg on a table connected by a string to another load B of mass 0.5 kg over a frictionless pulley. What is the acceleration of the system and the tension of the string when the string is released if A. The table is smooth, means it has no friction. B. The coefficient of friction of table surface is 0.2. This one has friction. So we do part A. Part A, he says smooth. Smooth means no friction. Friction is 0. Okay, guys, remember when we do forces, question about forces, you must draw the free body diagram first. Draw the free body diagram first. You have two objects. So when you have two objects, A and B, you must draw two free body diagram. Two bodies, two free body diagram. Okay? And show all the forces acting on the object. So for object A, it has the weight going down, M1G. Don't just write mg, please write m1g because A and B has different masses. Must put this as m1, this one as m2. So this one m1g, this one m2g. Okay, A has the m1g and has the normal force going up, perpendicular to surface, and is A is being pulled by B. So A feel the tension in the string. Feel the tension to the right. It's being pulled. Pull to the right. So tension to the right. And then B. So what forces acting on B? Its own weight, m2g going down. And also A is actually holding on B. A is holding on B. So B feel the tension going upward. You feel the tension. This string is still pulling on B. So tension, you feel the tension going up. So that's it. Okay, A has no friction. No need to draw friction. And of course, accelerate downward. B accelerate downward. Accelerate downward. So A also follow direction of B. Accelerate to the right. Okay? Good. Now we have finished our free body diagram. Let us do some calculation. Now we have two bodies. So we must separate into two bodies, MA and MB. MA is mass 1, 2 kg. Mass B is 0.5 kg. Mass 2. Now for mass 1, mass A, it only has, although it has two components, X and Y, we only use the X component. Because we no need to use the Y component because it has no friction. Friction actually is the formula for friction is mu kn. We only use the Y component to find the normal force. Why we want to find normal force? Because we want to find the friction. So we only use the Y component when we need to find the friction. Okay, friction, because friction depend on normal force. So right now, no friction, so we no need to consider the Y component. So the X component, Fx equal to m1a. Okay, so the X component, it has the, okay, before that, sign convention is very important. Okay, so remember we learned about this sign convention. When equilibrium, total force 0, no acceleration, no resultant force, we just say that going to the right, positive, going to the left, negative. Going up, positive, going down, negative. But when we have acceleration, total F equal to ma, or we can say it has resultant force, not equilibrium, then the sign positive is follow acceleration. Okay, follow acceleration, positive. Opposite acceleration, negative. Okay, follow acceleration positive, opposite acceleration negative. So now we need to put the sign first before we do calculation. So for x component, acceleration is to the right. So we can say direction to the right. Sorry, yeah. Direction to the right is positive. Direction to the left, negative. For the mass B, accelerate downward. Accelerate downward. So downward, positive. Upward, negative. Okay. So follow acceleration positive. Follow acceleration positive. Opposite acceleration negative. Yeah, negative. Now look at the mass 2. Mass 2. No, mass 1. 2 kilogram. So for S component, we have the tension. Tension is follow acceleration, so positive. So we just put positive tension. Okay. What else? Do we have other forces? No, we only have tension. So mass 1 is 2 kilogram. Just put 2. 2A. Okay. Right now we cannot find tension or acceleration, so we need helps. We need the mass B. So mass B, it has in Y component. Y component. This is Y component. Mass B, we have M2G is positive because follow acceleration. Tension is negative because opposite acceleration. So we just put mass 2G is positive because follow acceleration. So mass 2G positive, and then negative is the tension because opposite acceleration. So negative tension equal to M2A. So put in the values. 0.5 G minus tension equal to 0.5 A. Okay. Now this equation can substitute into the tension here. So we have 0.5 G minus 2A. Yeah. This one is from the mass 1. Equal to 0.5 A. So what do we get? Okay, so what do we get? We get acceleration equal to 1.962 meter per second square. We got our acceleration. Now we can find tension. We substitute here. We substitute back over here. 1.962, and we got our tension. Our tension is 3.924 Newton. Okay, that's our tension. Good. Now we solved the question A. Now B. Now the table surface has friction 0. This is coefficient only. Yeah. Be careful. This is coefficient, which is the mu only, mu k. Not the friction itself, but only the coefficient. So draw the free body diagram. Now it's rough. The surface is rough. Yes, the coefficient 0.2. Coefficient has no unit. Okay, so just add another friction here. Friction is going to the left because the motion is to the right. This object moved to the right, so friction is opposite direction, to the left. Okay. Now we have friction. Okay, we have friction. That means now we need to find, okay, let's write down the friction here. We have the mu. Okay, friction, how to find friction? Friction is mu k, and that's the formula. And we need to find, now we have friction, so we need to find the normal force. To find normal force, we need to consider y component already. We need to consider the y component, which has the normal force. We want to get friction, we must find the normal force. So that's why for mass A, we have x and y now. We have the y. We need to find the y. Okay. Okay. Now let's write down the sign convention. Like the y component, it is no acceleration. Yeah, y component Fy0, no acceleration. So just going up positive, going down negative. Okay, just put that down. Here going up positive, going down negative. But for x component, follow acceleration. It has acceleration to the right. Acceleration to the right. So follow acceleration is positive. Opposite acceleration negative. Same thing for the mass B. Follow acceleration downward is positive. Opposite acceleration is negative. Okay. Okay. Now set. Let's find out the normal force first. Yeah. Normal force. We consider the y component. So y component going up positive. So this is normal. Okay. Then minus the m1g equal to 0. So we got the normal force. It is m1g. So what is m1? m1 is 2 times g. So 9.81. We got the answer as we got the normal force. Okay, we just put it as 2g first. Okay. All right. So now we got the normal force. We can find the friction. So friction mu k. So we have 0.2 times the 2g. Okay. So we can get the friction, which is equal to 3.924 Newton. Yes, we got the friction. All right. Now we got the friction, we can find the x component. So follow acceleration positive. So tension is positive. Tension positive. And then friction, we have friction to the left. Friction opposite acceleration. So it's negative. So minus friction. So mass 1 is 2. Okay. So friction we got just now 3.924. Just put inside 3.924 equal to 2a. All right. And then we need to find tension at acceleration. So we can't solve this yet. We need to move on to mass B. Move on to mass B. We have we need to check the y component. Okay, Fy equal to m2a. So the y component we have mass. We have the mg and tension. Mg is positive because follow acceleration. Okay. So mass 2. This is positive because it follow acceleration. Tension is negative because opposite acceleration. Negative tension equal to m2a. So just put in the value. Mass 2 is 0.5. And then minus tension 0.5a. Okay, now we have two equations here. We have equations 1 and equations 2. So we can solve by simultaneous. So 1 plus 2. Then what do you get? Yeah. So the tension can be cut off. Yeah. Tension and negative tension cut off. So we solve it. We get 0.981 equal to 2.5a. And then we have what else we have? We find the acceleration equal to 0.9392 meter per second square. We got our accelerations. Next is we find the tension. Okay, our tension. Just put in the values here. This acceleration just put in here. We got our tension. So tension minus 3.924 equal to 2a, 0.392. So we get our tension. What's the tension we get? 4.71 Newton. Okay, that's our tension and acceleration for part B. Isn't it? It's so easy, yeah? So I hope you enjoyed the videos. Don't forget to like and subscribe and wait for my next video. Bye!